Hi everyone, this is problem number 3 from the writing equations activity from class. We'll do number 3 and number 4 in 2 separate videos. So this is number 3, and we're going to just start off by writing out the important information that you should have in your numerator and your denominator of your rational function. So for this particular problem, we have one vertical asymptote at x equals -3. So that goes in the denominator as x plus 3. And then my numerator gets two x-intercepts. I've got a 0 and a 1. That becomes x times x minus 1. Sorry, that's a 3. X times x minus 3. I'm ahead of myself here. That 1 is actually a whole. That does also go in the numerator because it's a whole, but the whole's at 1 negative a fourth. So x minus 1 also goes in the numerator, but because it's a whole, it also goes in the denominator as well. That way you can think of those two factors canceling away to create the whole. Okay, so now when I look at this, I see I have a horizontal asymptote at 2, but I don't have it written so that I can have a horizontal asymptote. I have the numerator's power is 3 and the denominator's power is 2. And we need to use one more thing that we can get from the graph to help us with this. So notice that the vertical asymptote at x equals -3 is going in the same direction, meaning on the left side and on the right side, the graph is heading both to positive infinity. And when this happens, the multiplicity on the vertical asymptote in the denominator is even. So that means I can put a squared on the x plus 3. That again is going to make the graph go in the same direction. So now I have a power of 3 in the numerator, a power of 3 in the denominator, but I don't have a horizontal asymptote at 2. The way we go about doing that is then making sure that the coefficients give us 2. So all I need to worry about is knowing that I'm going to put a 2 out front here and a 1 out front of the denominator. So I have 2x times x minus 3 times x minus 1 over x plus 3 squared times x minus 1. I have leading coefficients of 2. Both powers are to the third degree, and I have this whole that's going to cancel out. Once I get here, now I just want to check using a point that I have. So that's what this point was kind of there as a guiding value for you. You could also use the 1 negative 1/4 if you'd wanted, but you have to do you have to cancel out those x minus 1s first. So I'm going to do r of -1. So I get -2 times -4 times -2 over 2 squared times -2. So let's see what happens here. That goes away completely. This is a +4 and a -4, but the 4's cancel, and now I have a -2 times a -1, which is a +2, which is what that value was. So this is the solution to problem number 3.